Assalamualaikum everybody. So today we'll be going over self-referential structs and the kind of scenarios that self-referential structs can come up in. So we have a scenario in front of us that says that a city transportation department manages all bus routes in a large metropolitan city, and each bus route has a variable number of bus stops, and the number of routes can change over time as new routes are added or old routes are removed. And to represent this, we use a self-referential struct. Now, for those who are unable to recall, self-referential structs are structs that have a pointer to their own type, right? So, pointer to, okay, just a second to resolve this. All right, so it has a pointer to its own type. Right, so we have a struct bus stop. Let's deconstruct the member variables of bus stop. We have an integer ID, we have a string name. We may not be using this a lot in the question, but what you need to be mindful of is the ID and this next pointer that has type bus stop. So you know that if we have an integer pointer, it points to an integer variable. So naturally, a bus stop pointer will point to a bus stop variable. So a variable of type struct essentially. I hope this part is clear. So then we can move on and see what they want us to do with this information. They've given us a structure plan that says that a 2D pointer of type bus stop is created. And then it points to an array of 1D pointers where each 1D pointer acts as the head of a linked list representing a bus route. Let's see what that means. It says that we need to create a 2D pointer of type bus stop first. Alright, so we create a 2D pointer with two asterisks. Let's call it routes. This is a 2D pointers and it's called routes, and it needs to point to a 1D array of pointers. We know that any 2D pointer can store the address of a one-dimensional pointer. It can also store the address of an array of 1D pointers. For that, it points to the 0th element of the array, right? So in this case, it will point to the 0th element. And so we have multiple elements, suppose, depending on the size of the array. And at each index, we store a pointer. Pointer 1, pointer 2, pointer 3, pointer 4. And all of these pointers are essentially the head of a linked list. I know that you've not covered linked list in a lot of detail in class, so you do not need to be intimidated by the term linked list. It just means that it's chained structs, right? So, okay, so this is the head of one linked list, or this is the start of one route, okay? So to make this route bigger or to develop this route, you add more bus stops. This is one bus stop. You chain it to another bus stop. You can chain it to another bus stop. And how do we chain it? So we know that every bus stop has three elements: ID, the name, and a next pointer. And this next pointer points to a bus stop variable. So using this next pointer, we essentially point to the next element, right? This is the connecting point. And so this next bus stop will also have a next pointer, and so it will point to the next variable, and so on. And this will keep going on until we point to null. All right. So if suppose all of this will make up one route, right? And suppose if some route is empty, suppose P4 is an empty route, it has no bus stops. So then this is pointing to null already. This next pointer is going to point to null. And that will give you an indication that there are no bus stops in this route, so this route is empty. Alright, and if you want to traverse over this route, for example, so you go to the 0th index, you go to the next pointer of P1. So you say P1, wherever P1.next is pointing, you go to that element, and then the next pointer of the next element and the next pointer of the next element until you reach null. You can do that using a while loop. We'll see how that happens. If you want to add a stop here, suppose I create a new bus stop, right? And I know that I want to add it in P1. So I go to P1. I check if P1's next is empty. It's not empty. So we know that it's pointing to another bus stop. So then I keep iterating until it is null. And when I find the null part, I remove the null. I add my bus stop here, and then I point this bus stop to null now. So this is the new end of the list of the route. And if I want to add a new bus stop to P4, I know that it's already null. There are no stops, so I just add it at the start. I don't need to go to the end or to iterate it till the end. I just add the stop to the start. All right. Okay. So yeah, so this entire question is going to be based on traversing these lists. Let's see how we can go about doing this through code. I hope you've all understood the crux of the question and what we're supposed to attempt. Essentially, let's open VS Code. Okay, so for VS Code, okay, starting from the main function, we know that we were supposed to create a 2D array of type bus stop. So we create a 2D array of type bus stop, and we have to point it to a 1D array of pointers, right? So we say new bus stop, and then the size of the array, whatever that is. Suppose it's n, and we can declare n on top, right? So this should give us a, oh, I forgot to make it a pointer. It has to be a array of pointers, right? Okay, so notice how when I did not make it a pointer, it gave me an error, like it gave me a red line. That means that this is a 2D pointer, and so it can only store another 1D point, the address of a 1D pointer. It can't store an array of type bus stop only. It has to be a bus stop pointer. So I'll just add an asterisk here to make it a pointer. All right, and now I've already defined the struct here. I just need to fill in these functions now. So this is to create a bus stop. If we want to add a new bus stop, remember we saw already that if we want to add this new bus stop here, we first check if the list is empty. If it's empty, we add it to the start. If it's not empty, we add it to the end. So similarly, we first need to create a bus stop. For that, we make a bus stop pointer. And we dynamically declare a new bus stop. All right, so this has given us an instance of type bus stop. And we know that any instance of type bus stop has these member variables. We have taken out the name variable because it was irrelevant to the question. So we can say new stop, and using the pointer notation, we assign it its ID. So new stop has a member variable stop ID. It has a member variable called next. So we have assigned the stop ID to it because it was passed to us as a parameter in the function, but we do not know the next yet, right? So for next, we just pass null. We just point it to null because any new bus stop that we create, wherever it is added, even if it's added here, if it's added here, or if it's added here, the next is gonna be null because it's gonna be added at the end of the list, right? So that's why we keep the next pointer pointing to null. Oh, sorry, it's supposed to be next equals to null. All right. So once we've done that, then we can see that the return type of this function is bus stop. It's not integer, it's not void, it's bus stop. So it needs to return something of type bus stop. And what variable do we have here that has type bus stop? It's called new stop. So we just return new stop. All right, I hope this part is clear. Just take a few seconds to look at this and see if you understand it. Okay, then we move on to the next function, which is to add a bus stop. Again, as we saw that first we check if it's empty. If the linked list is empty, then we just attach it at the start. If it's not empty, we traverse through the entire list and attach it to the end, right? But for that as well, we first need to create a bus stop. And we've already established the create bus stop function. And we know that when we call the function, we need to pass it the ID. So don't forget to just pass the ID. Once you've done this, we now need to start with our logic of checking if our list is empty, then we attach it to the start. If it's not empty, we traverse through the list and attach it at the end. So we have been passed another parameter here. It's called head. Now this head refers to these P1, P2, P3, P4. These are the head of the linked list. So if these are null, it means that this list is empty. If these are not null, it means that the list is not empty and it has a bus stop inside it, right? Okay. So we say if not head, then so we check. Okay, so we check if head is null. That means that the linked list is empty, and so we can assign the new stop to the head, right? And if it's, you just simply return it. No need to go more forward in the function. And suppose if it's not null, if it does not go inside this if condition, then there are already some amount of bus stops inside the route. So we need to traverse to the end of the list. And for that, we first make a temporary variable. Once we have a temporary variable with us, we now need to traverse through the list. And what will be our condition? Obviously, we need to loop. So what will be our condition for the loop? That will be until we reach a null, right? So just using a while loop here that says that while temps next exists, meaning while it's not null, you just keep iterating, right? So we keep saying temp equals to temp next, and then okay, let's just focus on this part for now. We have made a temporary variable and we have assigned it head. Okay, so now this is pointing to one of these indexes, whichever one the user has called. Okay, and it checks if this is empty or not. And so for that it says if not head, then head equals to new stop. Okay, so our condition suppose did not go into that if condition. It means that this is not empty. It already has some number of bus stops like this attached here. And so for that, it will start a while loop that says while temps next exists. So while there is a bus stop after temp, you keep iterating and then you keep updating temp with temps next. suppose this was temp first, P1 was temp, and then it says while temps next exists. So temps next does exist. This is temps next. Then it says temp equals to temps next. So now this is the new temp. And then Iskabi next exists. So then this is the new temp. And then there's another next here. So we update temp again. And then finally it has reached the null pointer. So now it will exit the while loop. And so temp is now pointing to the last position. And so we can say now temps next equals to our stop, which was called new stop. Okay. You can see that this function is void, so we don't really need to return anything. We've just added a bus stop. So just for clarity, I am going to show you again what we've done. So we saw this array. It has multiple pointers. Okay, so first we checked if P1 was pointing to anything else. Is it null or is it not null? If it's null, then we simply say that this new bus stop that we've created, just assign it to P1. If suppose it already has some number of bus stops and P2 is not null or P1 is not null or P3 is not null, what we do is we make a temporary variable temp and we assign head to it. So suppose I called this upon P2. So now temp is P2, right? It checks if P2 is null. No, it's not null. Okay, then while temps next exist, does the next of P2 exist? Yes, because we have another bus stop attached to it. Then if it exists, then make it the new temp, right? So this bus stop is now the new temp. And then check if temps next exist for this bus stop. And it does exist because we have another bus stop here. So now the temp is updated. It is again updated here. And now finally temps next does not exist because this is null. And so we say exit the loop and assign bus stop here, new stop here, sorry. So this is our new stop now. This is no longer null. And new stops next was null. If you remember, we created that in the create bus stop function. I hope this is clear. Okay. So moving forward, we use kind of a similar logic for remove bus stop function. We simply check if head is null. Then you return because there's nothing to remove, right? And if it's not null, if it does have some number of bus stops, then you search for the stop with that particular ID. So they have given us the ID that we need to remove. So we say if head stop ID equals to ID, then how do we remove it? We make a temporary variable and we point head to it. Okay, then we say head equals to head point to next. We'll visualize this as well in OneNote so that you get a clearer idea of what we're trying to do here. And then you simply delete temp and you return. Okay. So what we're essentially trying to do here is that we have made a temporary variable, we have assigned head to it, and we have assigned head to its next pointer, and then we deleted temp. Okay. So back to OneNote. So let's visualize this in OneNote. So we're checking that, suppose we have this list, and we're checking if the ID of head is equal to the ID that we're supposed to remove. If it is, then we assign head to temp. Okay, so suppose this is assigned to temp, and then we say head equals to head dot next. So this was head originally, and heads next is this. So we assign head here. This is the new head now. This is assigned to temp, and so um, we can simply just remove temp, because this was the stop that we want to remove. This is the stop that we want to remove. We have assigned it to temp, and head is now heads next. So the rest of the linked list will remain the same. We just simply remove the first one, right? But that is in the scenario that the ID that we want to remove is equal to head. If it's not, then let's see what we can do. Okay. So similar to how we added a stop, that's that's exactly how we remove a stop as well. All right, so here we are trying to see okay, while temps next exists, it's not null, and temps next stop ID equals to is not equals to ID. Till then, we need to continue looping. And what do we have to do inside the loop? We just simply say temp equals to temps next. Alright, so this will keep going until we find the correct ID. We find the bus stop that corresponds to the correct ID. And so we know now that if temps, we suppose we found the ID, we now know which block has that exact ID that we want to remove. Now what do? We use the same logic that we used here for the head. If its next exists, just check if its next exists, then bus stop star temp. This is not used temp. We can use temp too maybe. This is temps next, right? Notice how we're just skipping the bus stop that you want to remove. Alright, so if this looks a little overwhelming at the moment, don't worry about it. We'll just go over this whole thing again. If you want to remove a bus stop, first check if head is null. If it is, just simply return it, because then the linked list is empty. If it is not null, then check if the stop ID of head is equal to the ID that we have to remove. If it is, then you make a temporary variable, temporary pointer, and you point head to it, and you point head to the next pointer, right? So let's just visualize this on one note. This is your array. Okay, just check if this is null. If it's already null, that means this linked list is empty. Return. If it is not empty, suppose it has some number of bus stops attached to it, and now you want to check if the ID is equal to head, right? So if this is the ID that you want to remove and it's attached to head, if that is the case, then simply check, you assign this head to temp and you bypass this head, right? So this becomes the new head now, and the rest of the things remain the same. Okay. Okay, after that, if even that is not the case, if head's ID is not matching, then you traverse the rest of the list to find the matching ID. And for that, you have created a temporary variable and you iterate over the temporary variable. We keep iterating over the temporary variable. We say, oh, is this where the ID is? No, it's not. Then you go to the next one. Is this where the ID is? No, it's not. So you keep iterating until you find the required ID. And suppose I know, okay, this is the bus stop that I want to remove. So I simply bypass this one. ठीक है, मैंने इसका next इसके साथ connect कर देना है with, and बाकी सब कुछ as it is रहेगा. I just have to connect the previous bus stops next with the next bus stops next, right? And bypass this middle node that I want to remove. And that is why we check while temp.next exists, so that we can get a pointer to the previous bus stop, right? Okay, so when we exit this loop, we have a pointer to the previous bus stop, and then we say if temps next exists, then bus stop star temp2, which is another temporary variable, will store temps next, and then temps next will become temps next. So this temps, this is the temps next will now no longer be this bus stop because you want to remove it. It will become temps next. So bypass कर रहा है उसको, ठीक है? And then you just delete temp2 because that is storing the node that we want to delete, right? Okay, this is also a void function, so we don't need to return anything. Okay, so next up we have the print function. And for the print function, let's just see how we can visualize that. We simply need to iterate over the entire kind of linked list and array, and we need to print it. Okay. So starting off with another temporary variable. So when we say while temp or while temp dot next or anything of that sort, that just means we're checking if it's null or not. So while temp means while temp is not null, and while temp exists essentially. So we need to print the root. So we say we assign head to the variable, and then we say while temp exists, you just simply output the ID that is a member variable for this struct, right? And if we just keep it this way, while temp and then see out temp stop id, it'll keep outputting the same stop id every time. So we also need to update temp within this loop. So we say temp is equal to temps next. Right, so temp is equal to temps next. And yeah, that's pretty much it. I think that'll print your root. So if we kind of dry run it, we know that this is the head. So we keep going to temps next, next, next. And at this node, at the last node, it will check if temp exists, and it does not because now this is null, right? So it will print everything except null, because at null वो while loop enter ही नहीं करेगा, because it will see that now temp does not exist. So if you want to output null, you just output it at the end, otherwise your loop, your traversal is complete without it as well. Okay, this was just one root, right? This was the root that was passed in this head. But what about all the roots? If you want to print all of them, because there were multiple roots stored in the array, remember every index of the array stored one root. So if you want to print all roots, you have to your simple favorite for loop. Just use that. Okay, so till when do we loop? We know that we have this 2D pointer roots, right? We needed that because that's pointing to our 1D array as well. But how till when do we loop? So we use this num roots value. This tells us how many roots we have in our array. So we loop till num roots, and we simply print. If you want to print like the helper statements that tell you what you're printing, you can simply just say root and then the number of the root. So it's gonna be, should ideally start from 1, right? This will tell you that root 1 is printing and root 2 is printing, root 3 is printing. Alright, and then you have to print the actual root, and for that you do not need to write any long logic. You already know how to print one root in this function. So you just Alright, so my laptop died, so there is gonna be a break in this recording. Anyways, so we were printing all roots, and I was telling you that you do not need to write all of this again because you've already written the function to print one root. So just call that function for each root now, right? So we have the roots array, and we call the print root function on each index of this array. I hope that makes sense. And I have added the wrong brackets. Alright. Okay, so this loop will run over all the indexes, and it will call print root, and print root will print each root for this. Then we have our last function, which is delete root, and that's pretty simple. So while head exists, while it's not null, you just make a temporary variable of type pointer, assign head to it, keep saying head equals to heads next to iterate over it. Okay, and you simply delete them. So we are assigning head to a temporary variable, and then we're moving head to heads next, and we keep deleting temp साथ, right? So we keep moving to the next pointer, right? Let's just visualize here what we're doing. Okay, so if you want to delete this entire root, what we're doing is we're assigning head to temp, and then we move head to the next stop, and we delete the पीछे वाला stop, right? And then we move head to the next stop, and we delete the previous stop. Then we move head to the next stop, and we delete the previous stop. That way we're able to iterate over the entire root, and we're also able to delete it साथ साथ. Okay, now that we have all of these functions implemented, we need to call these functions now one by one in main and see how we can do that. Let's see. Okay, so we already have our 2D array made, 2D pointer made, and 1D array. So now we just need to initialize all of this. ठीक है, सबसे पहले let's initialize all of these roots. So int I equals to 0, I is less than n, I plus. We do this to make sure that there's no junk value stored anywhere and it's all null, right? So ये जो हमने array initialize कराई है, we initialize all of this to null initially, and then the user can store stuff in it. So this is all becoming null essentially. Okay. Once we're done with that, now we start making calls to our functions. Suppose we say I want to add bus stop. Now remember the arguments that we needed to pass to this function. This is the add bus stop function, and we need to pass the head argument and the ID. Okay, so the head can be passed by indexing the roots array. So suppose I wanna add it into roots 1, or any index really, it doesn't matter, and then you give it some ID. So if it's 100, suppose, and then you all right, so we can add another bus stop. We keep adding multiple bus stops here. We can also call the print roots function, then we can call the print all roots function. The remove understood this question. If this is too overwhelming, just take a step back and go over the entire logic again, try to visualize it, and then you'll be able to understand it better. Let's also visualize this on Python tutor to make you understand. Alright, so I've added this code on Python tutor. This has all of the function calls, etc. as well, but this is essentially the same code by logic that we've coded. Let's move through it step by step. So if you keep pressing step, it'll keep taking you to the next steps, right? So, all right. So here, as you can see, it is declared a 2D pointer roots, and it is now pointing to a 1D array of pointer to bus stops, right? Then you move to the next step where they're all initialized to null. Okay, so this for loop initialized all of these to null. Then we call the add bus stop function where, let's see what it does. So okay, so it's pointing the add bus stop's head is pointing to the 0th array, okay, because that's what we called it on. You can see here, where's the call? Yeah, so it's root 0, right? So that's why it's pointing to the array's 0th index. Then we call the create bus stop function. So it goes to create bus stop. It creates a new stop. So there is now a new object of type bus stop which has stop ID. Next, in stop ID we assign the ID. In next we assign null. And now we are back to the add bus stop function, where the new stop function is created and it is pointing to the new object that we created. So I'm just going to let you see what these visualizations are doing. It checks if head is null, then head equals to new stop, and since head was null, now head is pointing to this new stop. Okay. And we skipped all the other things because we have used the return statement here. So after pointing head to new stop, we can simply just move to the next function. All right, so we're adding another thing. So just see how it does the same thing over again. But this time, since head is not null, so it will use a slightly different path. Yeah, so head was not null, so they assigned head to a temporary variable and then it looped through the whole path. Alright, so this is just going to be adding more bus stops. You can practice this on your own as well. Alright, one more bus stop and then we print all the routes. Alright, so as you can see that number of routes was 5, so it looped 5 times, called the print route function. The print route function iterated over the entire route for each index of the array. Okay, so I won't go through all of this, but you can definitely try this at home. I'll attach the code for your reference. Okay, and I recommend that you go through all of this. Okay, very few lines are left, so might as well just go over it. This is again printing a route after removing an element. And now this is gonna delete a route, so watch how it deletes an entire route from the index. It's printing the routes right now. Alright, so at the end, okay, let's just move a little. Yeah, so it's freeing up all the memory, right? So you can see all the routes have disappeared at the end because we freed up everything. So this was your function. Practice this at home as well so that you can get a better understanding. I hope this was helpful. If there are any questions, just feel free to DM me on Slack or leave a comment or something.